是让我们吗？
All right, now it's 8 o'clock. I think we can start the webinar officially. Hello, everyone. My name is Mingming. I'm associate professor at Tongji University. I'm also serve as the general secretary of the Chinese National Group of IABSE. It's my honor to moderate this webinar today, and we have a very high-profile presenter today. So before we start the webinar officially, let me give a very short introduction about IABSE. So I'm gonna share my screen now. Okay, you guys can see my screen, right? 朱总看得到我的屏幕吗？
Yeah, we can see that.
Okay, good. So all right. So IABSE is stands for International Association for Bridge and Structural Engineering, and this is its official website address. Its mission is to exchange knowledge and advance the practice of structural engineering worldwide. So it focuses on many aspects about bridge engineering and structural engineering. It has members from over 100 countries. So it's a very influential international organization. So IABSE has members in over 100 countries and has over 60 national groups. It was founded in 1929, and its center is located in Zurich, Switzerland. So IABSE deals with many aspects of structural engineering, for example, the science and the art of planning, design, construction, operation, monitoring, maintenance, rehabilitation, and preservation. So many aspects. So almost every, no matter which area you're working on in structural engineering, civil engineering, so IABSE is a good organization for you. So we welcome all people from the academia, from the industry, from the construction. We welcome you to join our association. Our current president is Hashavada Subaru. So he was elected last year, and he's from India. So the main objective of IABSE is to promote the cooperation and understanding among all those concerned with structural engineering and related fields by worldwide exchange of knowledge and experience. So for this purpose, IABSE has organized the conferences worldwide. So we usually hold two conferences every year. One's called symposium, usually happens in April. One's called Congress, usually happens in September or October. IABSE also publishes high-quality journal papers. The journal is called SEI. It also publish reports and books, and also have program for young engineers, which is called Young Engineers Colloquium, YEC. I'm also one of the members of the YEC. And another important activity from IABSE is that it gives world-famous awards for people and structures every year. These are the pictures of this conference and activities held by IABSE. This year, so the symposium was held in Copenhagen, in Denmark, and our upcoming conference is in Incheon, in South Korea, in September. So the registration is still open. So if you want to attend this conference, you can still do that. Next year, we will have two conferences in Guwahati in India, which is in April next year, and the Congress will be held in Milan in September. So you're very welcome to attend these two activities. For the IABSE, the most famous publication channel is called Structural Engineering International. This is science in SCI indexed journal. And we also have bulletins. I also serve as a member of this bulletin board. So the bulletins will publish documents, reports about in many different fields and perspectives. And we also, for the conferences, we also have proceedings published. And we have, as I said before, IABSE has over 60 national groups. Like Chinese group is one of the most influential group with many members. Now we welcome you to join the IABSE and also join the national group of your country. For the technical activities, IABSE has an association called task groups. So if you are interested in one specific area, or for example, for the design, for the construction, or for some other aspects, so we have many different areas. You can choose one task group and apply and join it. So you can publish some of your studies, your reports, your thoughts, ideas. Yeah. And wait, 怎么样让它没有隐藏起来？这为什么一直显在最上面？ Okay, never mind. So this, if you are younger than 35 years old, you can join the Young Engineer Colloquium. We call it YEC. So for this YEC activities, you have many benefits from it, and there are many tutorials and online mentoring courses you can attend, which are all free. And also for young engineers, your registration fee or membership fee is much less than the ordinary or normal memberships. These are some of the young engineer activities. You can apply for the prize and attend these networking activities, meet friends from international countries. Yeah. And we also have e-learning program, so you can apply and attend all these courses when you pass the qualifying exam. So after you finish all the courses, you will be issued a certificate of official certificate by the IABSE. Yeah, we also have webinars. As for example, today we have a webinar about the HuangHe SanXia Bridge. So we have many webinars on the website. These are recordings. You can watch any of it. And most important, IABSE has awards every year. And for the awards, I can show this video. So the award ceremony looks like an Oscar award night. So it looks very fancy and okay. So it goes to the YouTube. So it looks very fancy and cool. You go to Zurich, and the process looks like Oscar award night. And they will announce the winners for different categories of the awards. Okay, I will, for the time limit, I will skip it. All right. Okay. I think that's all my introduction about IABSE. Okay, so next, let's move to the webinar. Let me first introduce our presenter today. Mr. Yu Zhu, Dr. Yu Zhu is the Chief Engineer of Bridge Institute, CCCC, Second Highway Consulting Corporation Limited. Over the past 30 years, he has been engaged in design, consulting, research, and standards drafting of bridge engineering and some typical works such as Huanghe River Bridge, HuangHe SanXia Bridge in China. So today the webinar is about this bridge. Xuan Phuc Bridge in Vietnam, etc. He has achieved more than 20 prizes in national and province prize in excellent design, science, and technology progress award. The title of his presentation today is Challenges and Innovations in HuangHe SanXia Bridge, China. Okay, without wasting too much of the time, I will give the stage to Dr. Yu Zhu for his presentation. Okay, Dr. Zhu, can you unmute your microphone and share your screen, please?
Yes, we first show our video of SanXia Bridge.
这个共享吗？
At the bottom of the screen. 在底部有个共享。Okay.
对，这是这个。
3,000 years ago, the legend of HuangHe tells the ancient dream aroused in this land to move the mountains that blocked the local transportation so as to create a passage to the outside. This dream was mentioned the second time in 1957 by Chairman Mao, the founder of People's Republic of China. Today, we answer that ancient vow with a bridge. The world's first ground-anchored loop cable suspension bridge, the HuangHe SanXia Bridge. It soars across the Huanghe Mountain and Daimei Mountain, turning a formidable chasm into a thoroughfare and a legend into reality. This is not merely an engineering feat, but also an innovative breakthrough under the extreme constraints. Restricted by the fragile ecosystem, constrained by the challenging terrain, challenged by a vast span, guided by the philosophy of originating from environmental protection, starting with the anchorage, pivoting on the main cable, and culminating in the bridge form. The design team innovatively proposed the ground-anchored loop cable suspension bridge solution. A novel shallow overburden-type anchorage is placed atop the cliff, integrating the anchorage with the traffic deck to conserve resources. The main cables make a 180-degree turn within the anchorage for anchoring, eliminating the need for a splay saddle structure, which enhances topographic adaptability and design flexibility, cutting earthwork excavation by over 30,000 cubic meters and preserving the pristine landscape. The team tackled the challenge of arranging the loop cable strands by proposing an asymmetric 45-degree inclined arrangement method, which prevents wire twisting and ensures uniform stress distribution. The main cable saddle, turning saddle, and ground anchor bolt together form a restraint system, setting a precise dance for the robust main cables, achieving smooth turning and systemic self-balancing. Utilizing the tunnel's pilot drift as a construction access road to avoid the protected area, new techniques were developed, including pre-bending shaping of strands and two-way traction of folded and coiled strands, overcoming the erection challenge of the loop cable and doubling work efficiency. The Vermilion Bridge graces the verdant mountains and lucid waters, interpreting the spirit of perseverance while paying homage to the splendor of nature. A mega project can also become a harmonious stroke in nature's grand painting without conquering nature, which offered a replicable solution for construction in highly environmentally sensitive areas. This project, achieving breakthroughs in structure, design, construction, and environmental harmony, has been widely covered by national media, showcasing the beauty of synergy between engineering and nature. It is not only a transport link, but a fusion of ecology and wisdom. It connects not just two riverbanks, but also yesterday and tomorrow, honoring ecology through engineering and perpetuating heritage through innovation. There is a dream. It will become true one day.
Thank you. It's an excellent video. Although the video is not very, due to the internet delay, the video is not very, the pictures is not very smooth. All right, so Dr. Zhu, you can start your presentation. Thank you.
Okay.
Hello, everyone. It's an honor for me to join this webinar and introduce the challenges and innovations in HuangHe SanXia Bridge for Yuwu. And I'd like to introduce this by these 4 parts. Here comes to the first part, overview. Huanghe Mountain, Daimei Mountain, and the Yellow River have been great obstacles of the local transportation for our people since a long, long time ago, which can be aroused about 3,000 years ago. Just like the Chinese fable Yugong moves the mountains from chapter 5 of Liezi 450 to 375 BC, this story tells the ancient dream aroused in this land by Yugong to move the mountains to create a passage to the outside. And in 1957, our great leader Mao once remarked that we should follow the spirit of Yugong, who removed the mountains to transform China. Nowadays, in 2021, the dream was put into reality by costing RMB 9.82 billion yuan, about $1.44 billion, to build a 47.961 kilometers long Jingxing Expressway, include 29 bridges, 5 tunnels, and a width with 6 lanes. For such an enormous project, HuangHe SanXia Bridge crossing the Yellow River is the key control part of the expressway. The main bridge has the cable span for 555 meters, which is also the first ground-anchored loop cable suspension bridge, costed $260 million and opened to traffic in December 2025. And here comes to the next part, main challenges of the bridge. The first challenge is that the environment requirement is stringent, for the project is located in UNESCO Global Geopark, and due to the restriction imposed by the National Strategy on Ecological Protection, the environmental impact of this project should be minimized as much as possible. As shown on the screen, you can see that this area is also the habitat of the Chinese giant salamander and the hen harrier. And this figure shows the spatial relationship between the bridge and the Wangwushan Daimenshan UNESCO Global Geopark. And these two follow pictures show the great scenery of this UNESCO Global Geopark. The second challenge is that it is obvious to see in this figure that for the ground profile, the elevation difference between the two ends of the bridge is significant, and the Yellow River beneath is too deep. The project also has difficult construction conditions. The complex land topography, combined with extremely inconvenient temporary transportation, posed significant challenges to designing an appropriate construction scheme for the project. There had already been so many bridge-type design schemes available for reference. However, none of them could fully meet the construction requirements we mentioned earlier. So it is also a challenge for us to come up with a new one available bridge scheme based on the existing conditions. We specifically designed a number of new structure types, such as shallow overburden and anchorage and cable beam restrain system, which would be introduced in details in the follow part. Here comes to the third part. In this part, the innovation in HuangHe SanXia Bridge would be introduced in details. There are several key design points as following: adopting a longitudinal profile with a unidirectional slope and a single girder span of 510 meters, conforming to the terrain and spanning over the deep water, reducing the length of the tunnel on the north bank, and reducing the excavation volume on both the north and south banks. And these three pictures shows the original project site selection and its surrounding environment. The shallow overburden anchorage offers three key advantages: reduced excavation volume, a compact and convenient layout, and improved resource efficiency. As shown on this screen, we can clearly see that compared to spread cable anchorage, the looped cable anchorage can reduce the excavation volume significantly. This figure shows that the top space, we can see this part, top space, this top surface can serve as the roadway, and the U-shaped saddle room, this part. The U-shaped saddle room has sufficient space for workers to access and maintain. Here shows that we use this part, the tunnel's pilot drift, as the construction transportation access for this bridge, and the shallow overburden anchorage minimized the excavation volume. The main cable strands are arranged like this in a 45-degree direction with a maximum differences of only 2 strands between adjacent slots to ensure uniform stress. This is an on-set photograph of the main cable. The main cable consists of 121 prefabricated parallel wire strands. Each strand contains 127 pieces of high-strength steel wire. 3 saddle structures arranged in triangle. This part, one main saddle and 2 sliding turning saddles fixed on the Jian side. The L-shaped double sliding surface of turning saddles actively balances cable force on both sides. And we can see these 2 self-developed ground ankle rods can reduce 82% of vertical cable displacement during operation, greatly improving structural stability. This is an on-set photograph of main saddle, turning saddle, and the rods. And here comes to the girder and its restraints. We can see this left part. The girder adopts steel truss girder, and the bridge deck adopts an orthotropic deck. And near the pylon side, the cantilever brackets are located on the top surface of the bridge segments, and near the loop side, the cantilever brackets are located on the bottom surface of the bridge segment. And we can see the whole bridge girder adopts the steel truss girder. And under daily vehicle and wind loads, the girder acts as a simply supported beam to control longitudinal displacement. When an earthquake occurs, fuse devices break off automatically, converting the girder into a floating system. The wire rope dampers consume seismic energy to protect the whole bridge. And here shows 2 types of restraints. And we can see in this picture as for the new cable construction method, we invented folded coiled prefabricated strands and 2-end simultaneous towing erection technology, such as the picture shows, with self-developed special construction tooling, doubling the strand erection efficiency and shortening construction period. And this picture shows workers coiling the main cable strands in the factory. And this shows the coiled main cable strands are then transported to the construction site and then erected by 2-end simultaneous towing. By this environment-friendly low-carbon construction technology, we built a full green construction system to reduce construction disturbance, utilize the tunnel pilot drift as a permanent construction access, cutting transportation distance by 3.2 kilometers and reducing damaged vegetation area by 9,680 square meters. And we can see this part, the loop side anchorage served as a platform for strand construction. Through years of research and practice, our team has achieved abundant independent intellectual property achievements. We have published 20 journal papers, obtained 22 national patents, participated in formulating 15 standards, providing important technical new structure reference for seminar ecologically, sensitive area bridges. Now let me briefly summarize. The main logic to design the bridge is environmental protection, construction convenience, economic efficiency, and safety assurance. First, it sets a sustainable ecological design model for environmentally sensitive zones, guided by ecological protection. The design uses a unidirectional slope, shallow anchorage, single-span crossing, and U-shaped saddle room to minimize ecological damage while ensuring structural safety. Secondly, it achieves low-carbon full-cycle construction, factory prefabrication, assembly construction, and efficient cable erection reduce energy consumption, staged excavation and tunnel access, cut vegetation damage, supporting the national dual carbon strategy. As we can see, the total carbon emissions reduced by 67,381.7 tons. Third, it provides a green construction solution for mountain cliff areas, using pilot tunnel as construction passages and anchorage bodies as working platform solves the long-standing problem of limited construction space, maximizing protection the natural and space. Fourth, it integrates engineering aesthetic with nature and culture. The red bridge body echoes the Loess Mountains and the Yellow River. The smooth loop cable matches the river terrain. Connected with mountain tunnel, it forms a panoramic viewing corridor. This HuangHe SanXia Bridge has received wide attention and positive reports from many social media. Thousands of people pay close attention to its construction progress because it carries the ancient dream of breaking mountain barriers. As an old Chinese saying goes, once a dream takes root, it will never end until it is fulfilled. This project is not only a bridge technological breakthrough, but also a vivid practice of inheriting the spirit of perseverance and balancing infrastructural construction with ecological protection along the Yellow River. That's all for my sharing. Thank you for your listening, and I welcome your questions and exchanges.
All right, thank you, Dr. Zhu, and for the very nice presentation. Thank you for the translator as well. Okay, I think now we saved some time. I expect the presentation will be half hour, so we saved some time, which is fine. So for the audience, if you have any questions, please type your questions in the chat box, so the presenter can answer your questions. So in the chat box, if you have any questions, you can type your questions. Okay, I can ask a short question for myself while we are waiting for the questions from the audience. Dr. Zhu, so I can say this is a very nice project. You have presented many innovations, novelties associated with this bridge. For example, it only has one tower for suspension bridge, which is very special, very unique, and also you have a special sag and special loop cable. So among all these innovations, which one is the you think is the most important or you like most?
The most important maybe the shallow bottom anchorage. This is the pilot of the bridge. We concept this bridge from the environment protection and start with the anchorage. Then the loop cable and this operate this bridge.
Okay, very clear. Thank you. Okay, we currently don't have any questions from the audience. Maybe they're still typing their questions. I can ask a second question. So, what is the biggest engineering challenge during the construction of this bridge? And does this challenge has impact on the design of this bridge?
The most important challenge is minimize the disturbing the environment, because this Daimei and Wang is a geopark of the national. So the most important thing is to reduce the disturbance of the environment.
Okay, so to reduce this disturbance on the environment, because this is a geopark, so do you have any special design or process to protect the environment?
Yes, in the general conception was along the slope of the geometry of the land. The north side is low and the south side is taller. So we have the single lobe of 2% slope to along the slope of the Earth's surface. And then we use the anchorage surface as the base of the road, so we can reduce the road length. This was reduced by the anchorage volume and loop cable to reduce the height of the anchorage and can be separated widely along the surface of the Earth. That's all.
Okay, thank you for the answer. We have 6 audience. So, do you guys have any questions for Dr. Zhu? This is a very good opportunity for you to have interaction with our presenter. If you have any questions, just type your question in the chat box. Okay, so I'm gonna ask the third question if they're still thinking. So for this loop cable, this is a very special and innovative design. So it is loop cable can be widely applied to other projects, or this is only suitable for this special bridge. Can you hear my question?
是196年的1,000 and 9,060 MPa is a tensile stress. The safe factor is 205。
是不是可以这样回答呀？怎么回复啊？
嗯，
这线回答是吧？
对。说一下190召唤。开房是吧？开房。看人有那个前面不能扣的，对，
中国规范啊，选择性规范嘛。
我说一下。overburden-type。
Is named
公路选择性规范是吧？
啊，
公路选择性规范。公路选择性规范。
输一下。公路选择性。没有智能输入的。
公路选择性规范。
Highway Certain Bridge Code。规范没有呢？把
这个
规范打开直接就有了。
对，那你输进去吧。
规范。直接把规范打开就有。
或者截个图也行，放到那个框里。
碰瓷了，这个
specification 可以截图吗？
你怎么解？
截图怎么发过去呢？
先输吧。
哦，我们再输，稍微等一下。We are type the answers, just to wait for a second.
公路选择性规范。
那咋呢？规范打不了，它表面就有了。规范的封面上就有了。还是加明手。是。
Thanks for such interesting preservation. What is the tensile
这
strength?
个题回答过了，1960。
但是怎么还在这里？这是 answer 了，这是
down 是什么意思？点一个。
哦，
没有。
太房上面呢？太房。1960号吗
MLP。
那个 safe factor 你没再点一个。还有安全系数2.5。回答了一半。
安全系数是
safety factor 呢？它是问的。
safety 所以我们的 safety factors，所以这个是多少？
哪个？2.5的。看看这个2.5。
2.5。
Okay, thank you for the answers. Do you have any more questions from the audience?
我英语是
英语已经很厉害了，真的。
Okay, we don't have. Can I ask one more question? I'm just curious. So, uh, so Dr. Zhu, can you hear me?
Yes.
Okay. So now this bridge has been open to traffic for it's the December last year, right? So it has been 7 months. So it has been operating for 7 months. So has the bridge performance met your expectation since it opens for the traffic? And have you observed any unexpected behavior of the bridge?
Thank you. The bridge opened to operation last year, September. The stability of a big girder is very stable because we use a new vibration reduced device where rope damp restraints varying. This is first time used in the suspension bridge, but we have used for a cable-stayed bridge and cantilever continuous beam bridge before. Its performance very good in this suspension bridge. So when this device is vibration and earthquake reduce, both reduce device. So when the traffic and wind disturbs the beam, it can reduce the vibration.
Okay, good to know. So everything works just like it's designed, which is very nice. All right. So, okay, one more question from okay, let's comment from the. Okay, if there's no any more questions, I think I will close this session, this webinar. Thank you, Dr. Zhu, for this wonderful presentation. I have learned a lot from your presentation. It's a very good topic and a very brilliant project. Hopefully it can win the award of IABSE. All right. So thank you. See you in the future.
Was design speed.
Oh, we have one more question.
这个是多少？
设计风速。
Okay.
30好像是
35啊，35。
是吧？
Oh, all right. You guys, if you have any more questions, please ask. Any questions? All right. If we don't have any more questions, I will close this. Okay.
Thank
Okay.
you, Mr. Sun.
One more question.
主塔混凝土强度。主塔混凝土强。
Civil.
Okay, since we might have more questions, I will wait until 8:50. If by then we do not have any more questions, I will close the session. We still have 3 audience left. So if you have any questions, please ask. If not, I will close this webinar at 8:50.我已经没问题了。
关了也行。Thank you, Mr. Song.
Thank you. Thank you, Dr. Zhu. Thank you, the translator, for this wonderful webinar. And the audience have some questions. I think the interaction is very nice. Thank you. Hopefully, see you next time in person.
Thank you.
Thank you. 朱总，再见啊，谢谢。
See you later.